A journey to the nature of matter. Welcome everyone. We are here today to explore the nature of matter. We will learn how to observe, understand and gain a better understanding of matter in its most elementary forms. Through this journey, we will develop an appreciation for the mysterious and enigmatic world of matter. So come on this journey with us. Matter is all around us. It's the very fabric of the universe. But what is it? In scientific terms, matter is anything that occupies space and has mass. Early Indian philosophers classified matter into the 5 basic elements of air, earth, fire, sky and water, known as Panchtattva. We can further classify matter according to its physical state, such as solids, liquids, and gases. It can also be classified according to its chemical composition, such as elements, compounds, homogeneous mixtures and heterogeneous mixtures. Knowing the fundamentals of how matter is classified is useful in understanding the properties of matter and how it interacts with other elements. Matter consists of tiny particles that are separated by space and are constantly in motion. As an example, we can take a beaker of water and observe its level. If we take a glass rod and add salt or sugar to the water, the salt will dissolve but the water level will not change. This is because the particles of water fill the space that was between the particles of salt, demonstrating that matter is composed of particles. The activity shows that matter consists of incredibly small particles that move and are separated by gaps. When 2 to 3 crystals of potassium permanganate are put in a beaker of 100 milliliters of water, the particles of the substance disperse in a very minute form. If 10 milliliters of that solution is diluted with a further 100 milliliters of water 5 to 6 times, it can be seen that a few crystals of potassium permanganate can color a great amount of water as a result of the huge number of particles present. Matter exists in a variety of forms. We can observe the great distinctions between solids, liquids, and gases. However, what we cannot see is the space between particles. To show this concept, take a beaker of water and note its level. Using a glass rod, dissolve some salt or sugar in the water. It is evident that the salt has dissolved, but the level of the water does not rise. This is because the salt particles fit in between the water particles, proving that matter has empty space between its particles. Particle movement in matter is an amazing event. To show it in action, put some water in a beaker and add 1 drop of either blue or red ink on the side of the beaker. Keep it undisturbed and in a few hours, you will notice the ink has evenly dispersed throughout the water. This is because of the particles in the water and ink mixing together, which is known as diffusion. So, the next time you see ink blending with water, you will know it's due to the particles in motion. Matter particles are attracted to each other, making it difficult to break apart items such as an iron nail, a piece of chalk, or a rubber band. When an iron nail is hit with a hammer, when chalk is cut, or when a rubber band is stretched, this attraction between the particles of matter is the reason why it is so hard to break them. In terms of states of matter, we have solids, liquids and gases. Solids possess some particular characteristics, like having a predetermined shape and an unchanging volume. The gap between particles is very small and the attraction between them is powerful, resulting in the particles having very limited or no mobility. Additionally, solids are the least compressible and have the slowest diffusion rate. Liquids possess distinct characteristics that differ from both solids and gases. Unlike solids, liquids do not have a fixed shape, but instead conform to the container they are placed in. The space between particles is also in the middle compared to solids and gases, and the forces of attraction and movement of particles is also intermediary. Liquids are less compressible than other states of matter, and have a faster rate of diffusion. The image displayed on the slide is an example of liquid particles at different magnifications, with the smallest visible at the bottom right. Gases are fascinating substances that can take on any shape depending on the container they're in. These particles have a lot of space between them, and are characterized by having a minimal attraction between them and the maximum movement. Their compressibility is also quite impressive, as is their rate of diffusion, which is higher than that of liquids and solids. This slide contains a picture of a gas molecule which shows all these properties. Certain substances can change from one state to another when heated or cooled. Ice changes to water when heated and steam when further heated. When cooled, steam changes back to water and water to ice. This is due to the rearrangement of particles of the substance between each state. As heat is applied, particles in a solid move farther apart and become more spread out, forming a liquid. When cooled, particles move closer together forming a solid. This cycle of changes is termed a change of state. When a solid is heated, its particles start to vibrate with greater speed and have the ability to move more freely. When the temperature reaches a certain point, the solid will melt and change into a liquid, referred to as fusion. The temperature at which this occurs is known as the melting point. For example, ice has a melting point of 0 degrees Celsius or 273 K. The amount of heat energy needed to change 1 kilogram of a solid into liquid at atmospheric pressure, at its melting point, is called the latent heat of fusion. An image of melting ice in water with a thermometer at 0 degrees Celsius demonstrates this concept. Ice is a fascinating substance, with one of its properties being melting when exposed to water or certain temperatures. At 0 degrees Celsius, ice can quickly start to melt, resulting in a change of form and appearance. This slide provides an example of this process, with the assistance of an accurate thermometer. At a certain temperature, a liquid will start to boil and convert into a gas. Boiling is a bulk phenomenon, meaning that a majority of the liquid transforms into vapor. Water boils at 100 degrees Celsius or 373 Kelvin, and the amount of energy needed for this conversion is referred to as the latent heat of vaporization. This is an important concept in physical chemistry, which helps us to better understand the processes of energy transfer. Heat energy is a form of kinetic energy, the energy of an object in motion. It can be passed on from one object to another, leading to an increase in temperature of the receiving object. Often this energy is created through the motion of particles. For example, when a liquid like water is heated, it gains more kinetic energy, causing particles to move faster and acquire more space. This movement of particles is also seen when a solid such as salt is dissolved in water. The particles become separated and move around due to the added heat energy. Sublimation is a process where matter can transition between solid and gas states without going through a liquid stage. For instance, camphor or ammonium chloride, when heated, will turn directly into a gaseous form. When those vapors are cooled, they again become solid and regain their original form. An experiment to demonstrate this concept can be conducted using an inverted funnel, a cotton, a china dish and a burner. Applying pressure to a gas causes the particles to get closer together and the gas to transition into a liquid. Lowering the pressure and temperature can also liquefy gases. Compressed solid carbon dioxide is referred to as dry ice, and when the pressure is decreased, it changes directly to a gas without entering a liquid form. Dry ice is an excellent example of compression and is used in common activities like storing food in home cylinders. Understanding how states of matter interconvert can help us lead more effectively. Solid, liquid and gas are all convertible states, with fusion solidifying a liquid, sublimation transforming a solid directly into vapor, vaporization converting liquid to gas and condensation turning vapor into liquid. In order for these conversions to occur, the temperature and pressure must be changed. By learning and understanding the fundamentals of interconversion of matter, we have the power to lead more effectively. Evaporation occurs when a liquid turns into a vapor at temperatures below its boiling point. It happens at the surface of the liquid, when the particles gain enough energy to break away from the forces of attraction and reach a vapor state. Several factors can influence the rate of evaporation, such as surface area, temperature, humidity and wind speed. An increase in surface area will increase the rate, while an increase in temperature will also make more particles break off from the surface. An increase in humidity will reduce the rate of evaporation, but a higher wind speed will increase it. Evaporation is a crucial part of the water cycle. It is when liquid, like water, changes to vapor, or water vapor. The molecules in the liquid, due to the energy taken in from the sun or other heat sources, evaporate into the atmosphere. This process is done at a lower temperature than boiling, meaning the molecules don't have to be heated too much. This process is essential in many aspects of life, from the minuscule to the most essential. Molecules in a liquid can move around so quickly they can escape the surface, a process known as evaporation. This requires energy, resulting in vapor that is typically warmer than surrounding air. Evaporation is what causes water from oceans and lakes to become part of the clouds in the sky. Evaporation is an important source of cooling. When a liquid evaporates, its particles absorb heat from the environment and rise into the air, which results in a cooling effect on the surrounding surfaces. This process of evaporative cooling is used in everyday life, from keeping people cool through sprinkling water on the roof to wearing cotton clothing in the heat of summer, as cotton absorbs sweat and then evaporates, cooling our bodies. Evaporative cooling can also be seen in nature, with plants and animals relying on the cooling effect of evaporation to survive. It's an important process, and one that should be noted and respected. Evaporative cooling is a natural phenomenon that occurs when a liquid evaporates into the air. When the liquid evaporates, it absorbs heat from the air, cooling it in the process. This process has many practical applications, from cooling people in hot climates to refrigeration and air conditioning. The most common example of evaporative cooling is sweat, which is why we sweat when it's hot outside. Desert coolers are an air conditioner designed to counteract hot, dry air. Utilizing water vaporization and air movement, they can cool air efficiently while using minimal electricity. This makes them ideal for use in regions with hot and dry climates, such as homes and businesses, where other air conditioners may fail to provide sufficient cooling. To ensure optimal cooling from your desert cooler, follow the manufacturer's instructions and remember to replace the filters regularly.